So you guys have seen the law of sines. Next we have the law of cosines, and you see from the law of sines that depending on what you're given, so like when we had the law of sines, we could do the side-side angle case and we could do the angle-side angle case. Notice there are multiple other cases that they're missing. Like we could give you different parts of a triangle that wouldn't allow you to use the law of sines. So we can use the law of cosines in these two situations. Let's say you had two sides and the included angle. And the included angle means the angle that is in between the two. So this would be the side angle side case. And let me draw like a little generic triangle down here. So say we have A, B, C, then this would be little b, this would be little a, little c. If you had two sides, say you would like C and B and their included angle, that would be having little c, little b, and capital A, or you could have these two in this angle, or you could have these two in this angle. That's the side angle side case. You could also have all three of the sides. This is called the side case. So you could also have all three sides, and that would be the side case. So now we've pretty much got everything covered. If you're given three things, it's going to fall into one of the four categories that we've talked about so far. The two categories where you'd use the law of sines, and now these two other categories where you would use the law of cosines. The only thing that you are not able to do is the angle case. You can't do anything if they give you three angles. Remember similar triangles. Two triangles could have the same three angles, but one could be teeny tiny and one could be huge. You have to know at least one of the sides to be able to do anything with it. So here is the law of cosines. We've got three different forms, just like we do with the law of sines. You could solve this. We could do a squared equals b squared plus c squared minus 2bc times the cosine of a. That's one form. These formulas are going to seem crazy until I get them written down, and then you're going to see that they're all very, very similar. Second version, b squared equals a squared plus c squared minus 2ac times the cosine of b. And the final version is c squared equals a squared plus b squared minus 2ab times the cosine of c. Okay, so basically, it's the same formula that you're just using over and over again. So say what you have is C and B and capital A. That would lead you to use the first one. So if you're looking for the third side, you would use these two sides. That would go here and here. They would again go here and here, and then you'd use the included angle. Let's say you didn't have these three things. Let's say you had these three things. The formula looks exactly the same. You do this squared plus this squared minus 2 times this times the cosine of this. Or you do it over here. If you have these two sides and this angle, then you use the middle formula. So, like I said, it's basically the same formula, just kind of twisting the position that you're in on the triangle. Okay, so you could either have all three of these and need to solve for this, or you could have all three of these and need to solve for this. Those are the two ways that this particular formula works. So let's look at example 1. We've got triangle FGH. I'm just going to draw a very generic triangle here. I'll label some things on here. So FGH, we don't know what F is. We know that G is 82 degrees, and we don't know what H is. There are little degrees in there. We know that little f is 6, so that has to go across from the F. We know that little h is 4, so that goes across from the H, and we do not know little g. So when we tell you to solve a triangle, that means find all the missing pieces. So we are in the side angle side case. So the first thing that you're going to do, I'm going to write you down a step by step. First thing you do is you use the law of cosines to find the missing side. Okay, so just so we know what we're looking at, this is the side angle side case. So this is the step-by-step instructions for the side angle side case. Use the law of cosines to find the missing side. So let's write it down generically first. So here's our missing side. So we do g squared equals, then you put the other two sides squared, f squared plus h squared minus 2 times the other two sides times the cosine of the opposite angle to the side that you need. So now notice, that's exactly every one of these formulas is in this format right here. Missing squared equals the 2 you have squared and added together minus 2 times the 2 that you have times the cosine of the opposite angle to this side right here. That's the exact same format that these three are in. So we write it once, just kind of generically. Now let's plug in all the pieces. So f squared, 6 squared is 36, plus h squared, that's 4 squared, which is 16, minus 2 times f, which is 6, times h, which is 4, times the cosine of g, and g is 82 degrees. All right, so we get all that plugged in. So now the right-hand side, we have just all numbers, just a whole bunch of stuff plugged into that right-hand side. So what we're going to do is just plug that whole right-hand side in. So we've got 36 plus 16 minus 2 times 6 times 4 times the cosine of 82 degrees. And this gives you, oops, of course it gives me an exact answer. Let's try that again, sorry. This, about 45. So now, until you give your final answer, right now we're still kind of in the intermediate steps of things. You want to write down a bunch more digits while you're still in the intermediate steps. Write like 3 or 4 digits, but in the next step, let me show you something. So the next thing we need to do is we're going to square root both sides. So to get the g by itself, we're going to square root both sides. So I get g equals, to get an exact answer, here's what I would do. Type in your square root, and then just copy and paste this. That way you get a super, super precise answer. Okay, so hit enter, and we get about 6.7. Okay, so that is our missing side length. That's the first step, is we use the law of cosines to get that missing side length. All right, next we're going to want to find one of our angles, and now we're going to go back to the law of sines that we were just doing in our last lesson. So use the law of sines to find one of the missing angles. So either one, you know, if you've got a favorite letter, pick that one. Literally does not matter at all. So find the law of sines to find a missing angle. So let's say we want to find f. Okay, so we're going to set up this equation. Sine of f over little f equals the sine of g over little g. Now we're not going to use the h because we don't know what capital H is. So we're going to use this equation. So let's rewrite it with actual values plugged in. We do not know what f is, so we're going to leave that right there. Little f is 6 equals, and then the sine of g is 82 degrees, over little g, which is 6.7. Okay, so now we're trying to get f by itself, so what we're going to do is we're going to cross multiply. So cross multiply this way, and I get 6.7 times the sine of f equals, and then cross multiply this way, and I get 6 times the sine of 82 degrees. Okay, so we're trying to get this f by itself. So I'm going to divide both sides by 6.7. Okay, so these will cancel, and I get sine of f equals, and now let's plug in this right-hand side. So set up a fraction, and I get 6 times the sine of 82 degrees. And then if I wanted to be super accurate, oops, that's not what I wanted to do, just kidding. I was going to say we could paste that in instead of just using 6.7, but I think we will be fine with our approximation. Okay, so just 6.7. So we get this. So let's write a bunch of digits here. So 8868 should be good enough. So now here's what we do. If it's the angle that we're missing, you do inverse sine of this right here. Okay, so let's plug that in. So in our trig menu, we get the inverse sine. And now this is where we can just copy and paste this so we get a super precise answer. Okay, so for f, we get about 62.5 degrees. Okay, so now we just have one piece of our triangle that's missing, and that is the easiest part to get. When we're trying to find a third angle, all you have to do is subtract the other ones from 180. So very last step is to find the third angle, which, like I said, is definitely the easiest piece. So we know that f plus g plus h all together When I add up all three of those angles, I'm going to get 180 degrees. What I don't know yet is h. So to find h, I take 180 and I subtract f, which I just found out was 62.5, and I subtract g, which I knew from the beginning was 82, and that will give me my value of h. Okay, so I'm just going to plug this in. So 180 minus the 62.5 that I just found, minus 82, which is my value for g. Okay, so I get 35.5 for my last little angle. Okay, so now I have all the pieces. So one thing that I've mentioned before is that the order of the angles and the order of the sides should be the same. So notice h is my smallest side, capital H is my smallest angle. F is my next smallest size, the middle size, so capital F is my middle angle, and G is the longest side, so capital G is my largest angle. Those should go together. If you picture it this way, the smaller your angle, like this, the wider or the smaller the side is going to be. If I make my angle wider, those fingertips are farther apart, and so my side length is going to be longer. So it should make sense. It's a pretty quick way to see if your answers seem reasonable. All right, next let's look at example 2. This time we have a side, side, side situation here, so we're going to walk you through a different set of steps. So side, 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 it's basically the same 3 steps though. First, you're still going to use the law of cosines, but this time you're going to find an angle. Okay, so this part is very, very, very important. When you have the side, side, side situation, you have to go in decreasing order. It is very important that you find your largest angle first, and then you work your way down from that. Okay, so according to what I just told you, B, capital B, should be the largest angle because it's across from the longest side. So first we are going to find our largest angle. So use the law of cosines to find the largest angle. Okay, so here we go. So like we said, B is going to be our largest angle. So we use this formula. We use B squared equals A squared plus C squared minus 2AC times the cosine of B. Okay, so now we're going to plug everything in. So B squared is 11 squared, which is 121, equals A squared, which is 5 squared, plus C squared, which is 8 squared, minus 2 times A is 5, times C is 8, and then times the cosine of B. So B is what we don't know. Now here's something that is very, very, very important. I see people mess this up all the time. People are super, super tempted to just take the whole right-hand side in front of the B and just plug that into their calculator. Think order of operations though. This thing stays all attached. You cannot break that part up. People are super tempted to just plug this whole thing into their calculator. But remember, multiplication is stronger than addition and subtraction, so we have to keep this number in front of the cosine. So let's simplify up to our next row. So we've got 121 equals, we can feel free to add these. We can add right away with those. 25 and 64, we add them together, but then minus, now this we have to keep all attached. 2 times 5 is 10, times 8 is 80. Now it's going to feel super, super, super tempting to subtract these two numbers, but you cannot. Multiplication is stronger than subtraction, so that stays. What I do in this next step, though, is I subtract the 89 from both sides. All right, so that's going to cancel. So 121 minus 89, you could definitely plug these values in if you wanted to. So I get 32 equals negative 80 times the cosine of B, and then I'm going to divide both sides by negative 80. So make sure you're doing all of this appropriately. All right, so whatever 32 divided by negative 80 is, I plug that into an inverse cosine function. All right, so let's move over here where I've got some space. So if I want to find B, I take the inverse cosine of this side, 32 over negative 80. Okay, so we're going to plug that in. So inverse cosine of 32 divided by negative 80. That's going to tell me what my first angle is. Okay, so I get 113.6. I would round that 5 up. Oops, 0.6 degrees. Sorry, ignore that little dot. So that is B. That's my first measurement. That's step 1. Step 2 is, again, to use the law of sines. So now I'm going to use the law of sines to find the next largest angle, so the medium angle. So very important that you're going in decreasing order. So the next one would be the C. So 8 is the medium length side, so the medium angle would be side C. All right, so plug this in so we know B. So we're going to do sine of B over B equals sine of C over C, and we're just going to compile that all together so we can figure out what C is. So sine of B, we write sine of 113.6 degrees, and then over little b, which is 11. We know that must be equal to sine of C, and we don't know what C is yet, divided by little c, which is 8. And then, just like the other problems, you are going to cross multiply. So we cross multiply to both sides. So when we multiply here, we get 8 times the sine of 113.6 degrees equals, and then we cross multiply here, and we get 11 times the sine of C. All right, last step is we are going to divide both sides by 11, and then we're going to figure out what this value of C is. All right, so plug this all in, so we get 8 times the sine of 113.6, and then divided by 11. So we get this, and you want to write that whole value down. So we get sine of C equals 0.6664. So remember, to get C, you have to take inverse sine of this value right here. Okay, so rather than actually writing down the decimals and copying them all back in, we're just going to copy paste on our calculator. So hit the inverse sine button so we can find that angle, and then just copy paste that sine value. So our second angle C is 41.8 if we round to the nearest tenth. And then the last angle is always the easiest because we know that all three of them have to add up to 180. So since we already have B and C, A should be very, very easy. We know that A plus B plus C all together have to be 180. So if I want A, I just start with 180, and then I subtract B, which is 113.6, and then I subtract C, which is 41.8, and that will leave you with A. So 180 minus 113.6, and then minus 41.8. That leaves us with angle A, which is 24.6. Okay, so just like I was saying before, one really quick way to check if your answers make sense is that the largest angle should be across from the largest side, and then all the way down the medium side across from the medium angle, and the smallest side. So A is 5, and 24.6 is the smallest angle. So that's just a very quick way to see if your answers make sense. So last thing, this is going to kind of compile everything that we did with law of sines and law of cosines. Just a quick trick to see where you should start, because notice with law of cosines you do end up using the law of sines anyway. So if you start with two angles and any sides, that's what we talked about in the last lesson. That's what you're going to start with, the law of sines, and you can use the law of sines for both of those other pieces. And then if you have two sides and an angle opposite one of them, that's the side-side angle situation, you start there with law of sines as well. Those are the two sides, or the two, situations that we focused on yesterday. And then these two new situations today, the side angle side, you have to start first with the law of cosines to get that missing side. Or if you have the triple side situation, the side, 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 you have to start with law of cosines to get the first angle. And remember, you always start with the largest angle in that situation. So let's look at this last example here. So it says Amelia ran 6 miles in one direction. So just pick any point to be your starting point and draw a little segment, label that with 6. So that segment is 6 miles long. And then it says she turned 79 degrees and ran 7 miles. So if you look, this part seems a little weird. So if we go like this, that would be no turn at all, like if she kept going straight. But if she went all the way to the right, that would be a 90-degree turn. So turning 79 degrees would actually be like right here, like 11 degrees off of a 90-degree turn. So she goes this way, and then label that side 7 miles. So the question says, at the end of the run, how far was Amelia from her starting point? So connect her starting point with her ending point here, and that is the distance that we're trying to find. You can just label it with an X or whatever you want. So now we're going to use the law of cosine. So it's tricky because this angle actually is not 79 degrees. This angle right here is 79 degrees, and then we know these two together must be 180. So this angle on the inside of our triangle is actually 101 degrees. So be careful with that part. So label everything. We've got the side angle side situation. So we're going to use law of cosines to find this missing piece. So we start with an x squared equals, then we put one of the sides squared plus the other side squared minus 2 times the first side times the second side times the cosine of the opposite angle, which is 101 degrees. Okay, so these are nice and easy. When you're solving for the side, literally all you have to do is just plug that whole right-hand side into your calculator. So we plug in 6 squared plus 7 squared minus 2 times 6 times 7 times the cosine of 101. So that value, this is now x squared. So remember, your last step is that you have to square root. So just write down a handful of decimals here. Remember, we're going to get the exact answer anyway because we're going to do the square root of and then just reach up and copy paste that full decimal so we get a super accurate answer. So x equals, if we round to the nearest tenth, we've got 10.1. Since we're talking about a story problem, make sure you include their units, so it would be 10.1 miles. All right, so that is your last law of cosines problem.